Okay, so in this part, we're going to talk about speed of a moving object. And in the previous videos, in the previous three videos, we talked about distance, displacement, types of motion, and what motion is. Now we're going to go on ahead and start the topic of speed. You might have heard sentences like Ram is faster than Sham, and likewise, Ria moves quickly than Sia, something of this sort. So now, this faster word, something moves faster, somebody's motion is more quickly than the other person's. How can you actually prove? Is there some quantity that can actually help you in verifying whether whether that particular person is faster than the other one? Is there something like that which through which we can prove it? Yes. In that cases where you actually want to verify, or you actually want to know who moves more quickly, we can use the term speed. Speed is basically defined as the distance covered by a moving object in unit time. So how much distance your object covers in how much time basically is known as speed. If mathematically I can write speed as speed equals to s upon t, right? My s denotes the distance covered by your object, and t denotes the time which that object takes in order to cover that particular amount of distance, right? So how can I prove this, or how can I prove this through an example, or with the help of an example? I've considered here two boys, Ram and Sham, and I've said that Ram basically covers 1000 kilometer in 2 hours, and Sham covers 700 kilometer in 2 hours, right? So when I want to calculate the speed of Ram, it will probably be equal to 1000 upon 2, that is equals to 400 kilometer per hour, right? Per hour. And about Sham, his speed is going to be equal to 700 upon 2, and that is probably equal to 350 kilometer per hour. So from the value, from this particular value, I can probably say that Ram moves faster than Sham, right? Why? Because Ram covers more distance in 1 hour as compared to Sham. So through this example, we have proved that yes, speed does come in handy if you want to know about which particular person travels faster. So let's know now. So now we know what speed is. Basically, speed is defined as the distance covered by a moving object at unit time. It's a scalar quantity. Do remember that it's a scalar quantity. Why it's a scalar quantity? Because it doesn't really bother about in which direction you are covering your distance. It just considers that there is some distance being covered. It doesn't matter in which direction you are covering it. Okay. So speed is basically your scalar quantity. And if I want to know about its unit, it's distance. Distance unit is meter, right? And time we calculate it in seconds. So what is your unit? Basically meter per second, right? So that is the unit of speed. So now we've come to know what speed is. How can I even verify if someone is faster than the other person? Through examples I've also proved that as well, right? We've come to know. So now let's talk about the types of speed, right? What types of speeds there are? See, there are two types of speed. You've One type of speed is uniform speed, and the other type is, yes, obviously non-uniform. So I've got uniform speed and non-uniform speed, or you can also call non-uniform speed as variable speed because it is changing, right? So now let's try to understand uniform speed. Firstly, I will give a proper definition of uniform speed, and then you'll be see how this actually definition verifies. I'll give you an example which basically proves the definition of uniform speed. So what is uniform speed? See, uniform speed is basically that type of speed in which an object is, let me say that there is an object. Now that particular object is said to be moving with uniform speed if it covers equal distances in equal intervals of time. If some object is actually covering equal distance in equal interval of time, you say that that particular object is moving with uniform speed. For example, you've got a ball. I've got a ball and this is my path. Like I've taken a path and I've taken this particular path and I've plotted points A and E. Let me say that this is my road, or let me say that this is basically the floor of my home, and I've from the point where I started rolling the ball, I've considered that point as A, and I've also considered or put an obstacle at point E where I want my ball to stop rolling, right? So I say that my ball, I just say that the ball I'm throwing, the ball that is I'm throwing, what it does, what it's doing is that it's covering equal distance. I say that it is covering 10 meter every 2 seconds. Now I'm throwing my ball, this ball I'm throwing, and what is being done is that this ball is basically covering 10 meter every 2 seconds. That is, let me say that here some 2 seconds have occurred. Again here at this point some 2 seconds have occurred, and here also some 2 seconds have occurred, right? So what is I now these points where 2 seconds of time has gone by, I name it as B point, C point, and D points. So what is happening is that at every 2 seconds how much distance is being covered? 10 meter. So 10 meter every 2 seconds. So that means from A to B 2 second time has been completed, and how much distance has been covered? 10 meter. Again here 2 seconds, and how much distance? 10 meter. Again here 2 seconds and 10 meters. This point again is going to be 2 seconds, and again here 10 meter. So what has happened is that my ball is basically covering 10 meter of distance every 2 seconds. So now what the speed will be? You will find out that your speed with which your ball is moving is going to be 5 meter per second between any point in at any point between A and E, right? Like if I'm going to talk about this point AB, you will find that between AB the speed of the ball is going to be 5 meter per second. Again between BC the speed is again going to be 5 meter per second. Similarly, across CD and DE, the speed is also going to be as 5 meter per second. I can actually prove it. Let me say that the distance is 10 and your time taken is 2. Obviously, what I've got is 5 meter per second, right? So this speed, see, at every point your speed remains same. Your speed remains same, right? So this type of speed is definitely known as uniform speed. And when uniform speed is achieved, or when uniform speed is attained, when your moving object covers equal distance in equal intervals of time. So that is why we say that when your object covers equal distance in equal intervals of time, it is basically moving with uniform speed, right? So I hope this clears your concept of uniform speed. Any object, you find any object which is actually covering equal distance in equal interval, right? You will say that that object is definitely going to move with uniform speed, right? So uniform speed means your object is covering equal distance in equal intervals of time. And if you've got equal intervals of time uh, covering equal distance, then also you will say that your object is moving with uniform speed. You may also get questions like, somebody will say that the object is moving with uniform speed, so what type of distance will it cover? So answer is quite simple, right? If your object is moving with uniform speed, then there is no doubt that obviously it is going to cover equal distance. It will be covering equal distance in equal intervals of time. Likewise, if somebody is saying that some object is covering equal distance in equal intervals of time, what type of speed is he moving with? Obviously he is moving with uniform speed, right? So now let's move ahead. Now we are going to talk about non-uniform speed, right? Non-uniform speed. See, I'm going to prove it with the help of an example. Let's say that I've got a ball. Again, I've got a ball. Now I'm throwing my ball from some height edge from the ground. My ball is at some height edge from the ground, and I'm throwing my ball downwards, right? I'm throwing my ball on the floor. Let me see that this floor, what happens is that this I throw my ball at this point on the floor. Now what will happen when my ball strikes the floor? It is going to bounce back, right? But you will find that after bouncing back, the height to which this ball will move will probably be smaller than the initial height. Let's just say that this is h1 and this is h2, right? Again, from this point, what will going to, it will keep on striking, bouncing back, striking, bouncing back, right? But what happen is that at every point, the height to which this ball reaches will keep on decreasing, right? Say, look at it, it is going to be something like this. This is your ball, this is the height to which I've thrown it, and ultimately it will be like this. So, right, so this is my h1. Right now this will be your h2, this will be your h3, and now let's say that ball just now moves like this to the floor. So what has happened is that this is my ball, this is my ball, and what I've done is that I've thrown my ball from some height h1, and the ball, after being thrown, when it strikes the floor, it again bounces back, and but it bounces back to a height which is less than the initial height. Again, after that, it is again going to strike the floor and again is going to bounce back. So but with each bouncing, it is probably going to reach a height which is going to be less than the previous height. That is, h1 will be greater than h2 will be greater than h3. So h1 will be the highest peak to which this ball can achieve. After that, height will probably decrease. Height will decrease, which means distance covered is being decreased. The distance which this ball is covering is decreasing with the passage of time. As the time is being passed, as the time passes, my ball is covering unequal distances. The distance covered by this ball is reducing, right? So that means my ball is basically covering unequal distance. It is covering unequal distance in equal intervals of time, right? In equal intervals of time, my distance covered is unequal. So this type of speed in which you basically cover unequal distance in equal intervals of time is referred to as non-uniform speed. Whenever you come across an object which is covering unequal distances, but your time interval is constant, like I say that I've got a car, and the speed or the distance covered by that car is changing. For example, the time intervals are something of this sort: 0 to 10 second, 10 to 20 second, 20 to 30 second, right? For example, for the first 10 second, my car covered distance of 20 meter. Then my car, for the 10 to 20 second, for the next 10 seconds, my car covers distance of 40 meter. And after that, my car covers distance of just 15 meter. Is the distance constant? I mean to say that there is some sort of relationship between the distance that is being covered. It is covering equal. Is it covering equal distance? Obviously no. My time intervals are actually equal, right? But that is of 10 seconds. But what is happening is that basically my moving object is covering unequal distance in equal intervals of time. Then the speed with which this sort of object is moving is non-uniform speed or variable speed. So from this whole video, three main points that we need to remember at the end are that: first, speed is basically how much distance your moving object covers in unit time. Now speed can be uniform and speed can also vary. When can speed be said to be uniform? If your moving object is covering equal distance in equal intervals of time. You say that that particular object is moving with uniform speed. However, if your object is covering unequal distance in equal intervals of time, then your object is covering non-uniform speed, right? Another main point that you need to remember is that speed is a scalar quantity. It has only magnitude, it's got no direction. So it doesn't matter for speed, for this particular quantity, in which direction the distance is being covered.